Well, hi everybody, and welcome to our very first homeschool program. I am very excited that you are all here with us to share in this experience, and I'm very much looking forward to showing you some really cool science today. So my name is Dr. Scientist Ben Ross, and I am from the Omaha Children's Museum, and that's where we're streaming from right now. We are actually in the STEAM cave inside of the Omaha Children's Museum. And today, we are going to get to do some really neat chemistry experiments and look at chemistry in action. But before we do that, I want to say one quick thing. This is supposed to be a little bit of an interactive experience for you guys. And so what I would like you to do is, as we go through the program, if you come up with a question or you want me to explain something more, or you have something that you want to share, please put that in the chat. Most questions we will wait until the end of the experiments to discuss the question and to talk about them. But if it's really pertinent, I have a friend back there behind the screen who's helping me out today, and she'll let me know that I have a question and I can answer it for you guys then. So please take that time to interact with us. I'm so excited to hear all of what you have to say here at the end of the program. As we get started today, we are talking about chemistry. Now, chemistry is the science of substances and elements and how they interact with one another. And so scientists that study chemistry often are looking at different interactions and changes. Sometimes they're chemical changes, and sometimes they're physical changes. Chemical changes are when chemicals and substances come together and they form a new substance. They create some sort of gas, or they create some sort of change in their makeup, in their molecular structure. And then a physical change goes from when something is maybe a liquid into a solid. So like when a piece of ice melts, that's a physical change. Water molecules are all the same. We haven't changed any of the chemistry of that water that was ice and is now water, but we are changing the way it looks. Today, our first chemistry experiment is a physical and chemical change. We are going to combine some chemicals today to create a little monster friend. Now, chemistry in the world today. One of the best ways that we can see chemistry used in our daily life, because it's not just chemistry scientists that use chemistry, we use it too. If you've ever baked anything or cooked anything, baking is a really good example of how we make chemistry work in our own lives. So when you bake a cake, for instance, when you bake a cake, if you've ever seen mom or dad make a cake at home, maybe you've helped grandma make some brownies, whatever that might be, before you put it in the oven, it looks kind of liquidy. It's kind of runny and soupy, just like these liquids are in my cups right here. They're kind of liquidy, they're kind of runny, they don't look like a solid cake yet. Well, cakes work in a very similar manner to the experiment that I am doing right now. When you combine all those ingredients and you apply heat, those ingredients begin to react together, and they combine together, and they go through what we call a chemical change, and they create your cake. And it becomes a chemical and physical change, because not only is it mixing together to create that cake, but it's also changing from that liquidy kind of goopy, soupy batter into a solid object. Well, today, when I combine my two chemicals right here, this is called polyurethane, part A and B. When I combine my polyurethane, I'm going to mix it up just like so. And I'm going to give it a second. As this begins to react, it's going to start to grow. And as it begins to grow, it's going to begin to fill my container, and it's going to start to harden. You see, what's happening is the chemicals that make up both my part A and my part B solutions right here that I combine together, they're going to react and combine together and bond together. And when they do this, it's going to cause this to actually grow even bigger than the cup I have right here. Now, as I touch the cup, I can actually feel that the cup is getting a little bit warmer. This is what we call an exothermic reaction. An exothermic reaction is a reaction that produces heat. So as these chemicals react together, they are creating heat because the molecules and the little structural bits that make this cup right here together they're rubbing up against each other as they combine. And when they rub together, maybe if you're at home, you can rub your hands together like this. You probably feel your hands start to get a little bit warm. That's from the friction, because the molecules are moving through and against each other, causing friction, causing heat to be released. So we can start to look at my object right here. It's starting to grow right here. You can see it. It's already filled the cup. It's going to keep filling the cup for a little bit longer. I'm going to let that keep filling that cup right there. Go ahead and just take a look at what's happening. It's starting to fill up that cup kind of like a cupcake would if you're making cupcakes in the oven. Remember, I kind of said that chemistry is similar to baking. Well, we just made a foam cupcake right here. It's filling up that container. It's growing and growing and growing, and we're still growing and growing. It's not quite solid yet. As you saw, I poked that with that stick right here. It's not quite a solid mass yet. But pretty soon, it's going to become a nice solid chunk for us. As it begins to continue to develop, I am going to start to put in a couple of our accessories here for our little friend. Whoop. Oh boy, it's really bubbling. This is going to look weird, guys. Especially because I used the hands as antenna, so that's super weird. There we go. We'll put a couple eyes on there. We have our little friend right here. He looks a little strange. But we created that nice little cupcake monster just like so. And then our little cupcake monster right here was made using the combination of those chemicals. So the chemical change was the substances combined together and they form a new substance. They form that complete parts of that foam. The physical change is that it started as a liquid, but now it's this solid chunk right here. I can't put my little pokey stick right here through the entire monster guy because it's a solid. It's kind of like a table or like a rock. It's a solid object. I can't pass through it. If it was a liquid still, I could dip this on in there just like I would if it was water or anything else. But it's that solid. I can't break through it. So that's our first chemistry experiment today. I'm going to go ahead and set this to the side. Set my other chemicals off to the edge there. There we go. I want to make sure we keep our science space nice and clean as we get on to our next experiment. Our next experiment, we are going to check out what happens when we combine some different chemicals together. So, as a chemistry scientist, or we call a chemist, they often will do experiments to view what it might look like if something were to be combined, to see how different elements and chemicals react with each other. Well, today I have some acetic acid right here, which is otherwise known as vinegar, and I have some sodium hydrogen carbonate in this little bucket right here. Now, this is also just called baking soda, commonly found in your kitchen. In fact, both of these things you probably have in your cupboards at home. Well, what I'm going to do is I'm going to dump this in here, and I want you to watch the reaction right here. Maybe we can switch to camera 2 there, and we're going to see what happens. I want you to make some observations. So it's bubbling and filling up that container, and it's continuing to react, and it's overflowing, and we're making a mess, but that's okay because it's science, and we're allowed to make a mess in science as long as you have a towel. So we are going to make this mess right here. You can see that reaction is starting to finish, and it's not fizzing up anymore. Well, what we just saw there was a reaction between an acid and a base. An acid and a base, those are some ways that we classify various chemicals. And when we use that classification, if you combine what is classified as an acid and what is classified as a base, more often than not, you will have a similar bubbly reaction. Because what it does is that fizzes and it produces this gas called carbon dioxide. So we saw with our eyes one observation about what happens when we combine those two chemicals together. We saw that bubbling, that fizzing, that filling up. Well, we are going to step on over here to my candle ramp right over here. So I'm going to step on over here. Our camera will follow us in just a moment. We have our candle ramp right here. Now, I told you that this jar that I had earlier produced carbon dioxide when these chemicals combine together. I'm going to combine the chemicals together. In this Erlenmeyer flask right here, I have vinegar. I have another little cup of baking soda. I'm going to pour that together in just a moment. But before I do that, I want to explain what's about to happen. I'm going to light these candles, and I'm going to use the vapor and the gases from my jar to extinguish the candles. Now, candles need three things to burn. They need heat, which I'm using my lighter for. They need fuel, which is what the wax is on the candles. And they need oxygen. Oxygen is a type of air, it's a type of gas that's all around us in our atmosphere. So there's enough in this room for these candles to burn just fine on their own. Oxygen is a flammable gas. However, carbon dioxide is not. So when I pour the vapors out of this container, it's going to extinguish these flames right here. To get a better view of that, I'm going to turn down some of my lights right here. See if we can't better see those candles. There we go. So I'm going to go ahead and pour this on in here. It's going to fizz and bubble up. Now, as you watch, I'm going to do my best. No guarantees, because I'm going to be honest, I might make a mess again. But I'm going to do my best to only pour those gases down here and none of the bubbly bubbles. And the gas, that carbon dioxide, is going to go down here. And if my understanding of chemistry is correct, it will create carbon dioxide gas, and we can prove that by the candles going out. If it didn't create that gas, well, then these candles aren't going to do anything. So I'm going to let that bubble create that gas. I'm going to start to send that gas on down. We got 3. Can we get 4? There we go. I didn't spill any liquid down there. All of my candles have extinguished, and I don't have any flames anymore. I'm going to turn these lights back up. So I just proved that what I said earlier about that carbon dioxide gas is true. Not only did I prove that it has the property of being not flammable, right, of not being able to catch on fire, but I proved that that reaction did create that gas by sending it down that candle ramp. Let's get to another experiment here. This experiment right here is another experiment about combining chemicals. So sometimes when you combine different elements and substances, we get a fizzing reaction like what's still happening in the jar right here. It's still sort of fizzing and bubbling up. Well, I could also combine these chemicals in here. Now, these are some mystery chemicals. I'm not going to tell you what they are just yet, but what I am going to do is I'm going to show you the reaction. So you ready? Here we go. I'm going to pour this on in here. I'm going to pour this over here. Now have your eyes peeled, because once the reaction takes place, it's going to happen pretty darn quick. You get it all nice and mixed up here. There we go. And maybe we can zoom in on the table here. I'm going to set this down right here. I want you to keep your eyes on it. Go ahead and have a zoom on into this jar right here as I explain what is going to happen. So you guys can have your eyes on that jar, and I'm going to go ahead and talk a bit about what we are going to see happen here. So as this sits here, it's going to begin to react. Inside of my vial right here, there are a couple different chemicals. The main ones that I want to talk about, though, are hydrogen, and I have iodine. Iodine and hydrogen, when combined together in the presence of starch, will turn a blackish bluish color. This isn't blackish blue. Not yet, anyway. Along with my hydrogen in here, and my iodine, and my starch, I also have some vitamin C. Vitamin C has a property in which it'll slow down that reaction between the iodine and the hydrogen. And it's going to slow it down to a point where the iodine ions have to first react with the vitamin C until it's all been used up. Then, and only then, will we begin to see the bluish blackish reaction from the hydrogen and starch. So as this continues to react together, we're going to give it a little bit more time. It'll go eventually. Keep your eye on it. I'm going to give it a few more seconds here while I take a sip of water, and then we're going to go on. And there we go. We have our reaction take place. That was very, very neat. You guys can see that happen almost slowly but instantaneously, right? We have that reaction as it goes through those iodine ions and that hydrogen peroxide that I had in here. They're reacting together in that presence of starch, creating that blue-black water right here. It didn't happen right at first because we had that vitamin C in there. So, chemistry at work. We can use chemistry to not only delay reactions, but to create reactions. We actually used as an added experiment right here. Go ahead and take a look at that. I have in this vial right here, it's just some leftover vitamin C from when I created my solutions. If I pour this in here, and I mix it around, there we go. I'm gonna mix it, do a little bit more, not a whole lot more, just a little bit more, there we go. And that reaction is starting to actually change back to that clear formula like that. It's not as dark now as it was before. So we can even reverse that experiment by adding in that vitamin C again. Now, of course, eventually all that vitamin C will react with the iodine ions. It'll turn back to black. But until then, it's going to be that kind of muddy, clear color that we have right here. All right. So we've talked a lot about different chemistry experiments today using some chemicals. Now I want to talk about some chemistry experiments that you could do or see at home. For instance, we use chemistry in our everyday life. Every day we use chemistry, like baking, or like when we are preparing different cleaning solutions or using cleaning supplies. Maybe you use chemistry when you are maybe putting on makeup or using nail polish, right? Those are all things that involve chemistry, involve elements and compounds working together. Well, another example is using sunscreen. That's right. Sunscreen is chemistry. I have right here a bottle of sunscreen that I bought on sale yesterday because it's winter. And I have, now okay, real quick, the reason I had to buy it yesterday is because apparently nobody in the museum is carrying sunscreen on them in November. I asked around, nobody had any, I didn't have any in storage, it's fine. I got it yesterday. I also have this piece of paper right here. Now, sunscreen is used to keep you from getting a sunburn, right? Sunscreen is used to keep the sun and its rays of light, or its radiation, which we call UV light or UV radiation, away from your skin. And it does this in two different ways. You see, you can have inorganic chemical sunscreen, and that has chemicals in it that help to repel or reflect sunlight. So it has ground up metals and elements like zinc and oxides that help reflect that sunlight. Then you can have organic sunscreen, which is more or less what's right here, and it's a chemical sunscreen that uses more organic elements, elements that absorb light and absorb that UV light before it can get to your skin. To best demonstrate that, I have right here my little UV light. I'm going to go ahead and turn down the lights. We'll switch to the overhead camera. There we go. Now, looking at this paper, it was white. Now it looks kind of bluish. I'm using my UV light right here that artificially creates that light similar to the radiation that the sun creates, but a much lower level. Right now, we don't see a whole lot happening, right? The entire page lights up, okay? Just want to make sure I prove myself really quick. There we go. Okay, the whole page lights up. Now we're gonna stay with the overhead camera for a second. I'm just gonna go ahead and turn that light on so I can see what I'm doing. Bottle of sunscreen on my hand. Rub it on in, right? I'm gonna add a nice handprint right there. Perfect. That is a perfect little handprint. Now, you might be able to see a little bit of some water, maybe oily marks. It's not gonna dry completely yet, but it would eventually. I'm not gonna go ahead and wait for it to dry though. I'm just gonna leave it be. Remember, earlier I showed you this. There was no marks on the paper, right? I have not flipped the paper around. I haven't done anything with the paper. We're simply just going to observe the chemical reaction that is caused between the UV light and the sunscreen. Now when I shine my light on there, we can see that handprint from where my sunscreen was. The reason is this. My paper is white and it's reflecting that UV light. It is reflecting it so that our eyes can see it. Well, when something's reflecting something, it's not being absorbed by anything. It's not being stopped by anything. So my paper is just simply reflecting the UV light. In fact, I guess you could walk outside and cover yourself in paper and probably be okay. Right? The sun may not burn you if you're covered in paper. Clearly, it's reflecting it very, very well. Well, where the handprint is, that's where the sunscreen was. The sunscreen is actually absorbing that UV light. The chemicals inside of the sunscreen are created so that they can absorb that light before it gets to your skin. So even though it's absorbing that light, it might be getting kind of warm, it's not letting that radiation get to your skin. It's being stopped. Now, what I want to point out, though, really quick is this. Notice that like up here is a little bit darker than like down here, and that there are some other spots around here. You can kind of still see some blue light kind of bounce off of there. It's not completely pitch black and dark. If I put it like on my hand, right, my hand is pretty dark. You don't see a whole lot of reflection of that blue light on here. That's because this is only SPF 30. It's not absorbing all of the light that it could. It's not absorbing all of that radiation that it could. If I had something of a bit higher magnitude for my sunscreen, we would see a little bit of a darker handprint than we do right now. So chemistry in action, my friends. You have it at your house. We're going to turn those lights back up. We're going to keep moving forward to our next experiment right here. Another example of chemistry that you might have and use in your life. Is this right here. This is called a glow stick. A glow stick creates light through a chemical reaction. In fact, the science that a glow stick uses is what we call chemiluminescence. And it's a study of how chemicals can combine together to create light or photons of light that we can perceive with our eyes. You may have also heard of bioluminescence before, like in lightning bugs and glowworms, and that's where you use organic and natural ways to produce light, and we're not going to talk about that right now. But we are going to talk about using chemicals to produce light. Chemicals to produce light, regularly with a glow stick, what would happen is I would crack my glow stick just like so. You hear that crack, shake it up, and we have this lovely glowing glow stick. Maybe we can see it better on the overhead camera. I'm not really sure. It's kind of light in the room. But we have our glowing, there you go. Yeah, we have our glowing glow stick, and we can see that it's now shining a nice, lovely light, just like so. Well, what happened is this. My glow stick is made up of two different parts of it. There is the outer container, and that outer container contains one chemical that's used. It contains something called hydrogen peroxide. So hydrogen peroxide is in the outside of my container. Inside of here, there's actually a glass vial full of another set of chemicals. And those chemicals, when they combine with that hydrogen peroxide that's on the outside of that inner vial, of that inner glass tube, they create this glow. That's why when you crack a glow stick, you hear that cracking sound. It's actually breaking that glass vial inside of here. What I have done, however, is I have gone through and I have separated out the two parts of my glow sticks. So I have, in each of these vials, I have the clear liquid right here, that hydrogen peroxide liquid. And then I have my colorful liquid, and inside my colorful liquid, it has the dye for the color as well as that the other chemicals that are needed to make it glow. Now, what I can do with this is I can combine them together, and they will start to glow. But after I combine them together, I'm going to do something else. In one of the vials, I'm going to add 1 or 2 drops of just regular dish soap. That's going to help me create a brighter glow. It's also going to cause that reaction to happen much, much quicker. So we are going to go ahead and turn these lights down again. My overhead lights down. I'm going to turn off all the lights, I think. Yeah. Okay. So regular glow stick right here. I'm going to combine these together. So we have our first glowing vial right here. I'm going to combine these ones together. Now, it'd be pretty fair to say that these are glowing at about the same intensity. We'll see if we can't vary that up here. It might be kind of hard to see on the camera, but we're going to go ahead and try it anyway. I'm going to go ahead and drop 2, 3 drops of soap in there and start to mix it up. And we're going to see if we can't make this one just a little bit brighter. Now, I can see it here, and I think you guys can even see it on there. We can see this one has a little bit of that glowing or brighter glowing shine to it than this one right here. It is a little bit brighter. It's kind of hard to see. So this is the one that's a little bit brighter. Maybe you can see that better on the overhead camera. Brighter, not as bright, right? This one's starting to dim out now a little bit. It's not a whole lot, but it's a little bit. It's starting to become a little bit dimmer. And now they're about equal again. There was a split moment there where it's a little bit brighter. Let's see if I can't add the soap into here and maybe we can see that reaction happen again. So a couple drops of soap, brighten that up. Now I can tell in here, oh, there you go. This one's now the new bright one. And this one's a lot brighter than this one. You can kind of see that maybe against my jacket there. This one is reflecting, this is the one with the soap. It's reflecting a lot brighter on my jacket than this one is right here. They're at the same spot, but this one is shining a lot more of that jacket than this one is right here. This one's not as bright anymore. So we can use those reactions to create and change how the chemicals react together. We added another substance, and that changed how the chemicals were working together. When I added in that soap, as you can see, so this one right here is still glowing. This is the one I added soap to the second time. This one that I put soap in the first time has already stopped glowing. It looks kind of like a sad, non-glowing glow stick, as if it's been on for a while. It caused that glowing reaction to happen a lot quicker. That soap helped to absorb some of the oils used in the glow stick, and in doing so, it allowed for more of the hydrogen peroxide to react with the other elements in there, but then the hydrogen peroxide reacted with those other elements a lot quicker. So there's more peroxide in there to react with the other elements that create the glowing when I added the soap in there, because that soap absorbed some of the other particles and chemicals that help make it glow. And as it did that, it caused it to glow a bit brighter, caused that intensity to be brighter. But it's also making it not last as long. So it's a fun little thing to try. Worth looking at, if you ask me. All right. I have a couple more experiments for us today. This next one is quite interesting. So today, we are going to perform a scientific test to see what happens to certain chemicals when they are under heat and flame. Now, these chemicals on their own aren't flammable, but they are going to have an interesting effect on the flames that we see come off of them. I need to quick grab a pipette, which is a little dropper right here. I'll use my little dropper right here to help me put in my element right here. Now, I told you, if I just apply a flame right now to my little container of my chemical right here, nothing's really going to happen. It's not a flammable chemical necessarily, but it will burn. It just won't fuel the fire. What I'm going to do is I'm going to add in some ethyl alcohol right here. This is about an 80% solution. This is going to burn, and I'm using the ethyl alcohol because it creates an almost non-existent or non-colored flame. And so it's going to help me showcase that color a little bit better. So I'm going to go ahead and turn down the lights again so we can see it just a little bit clearer. Turn off that overhead light. There we go. Let's see if that works. This is, our first chemical is called borax. Borax, in the presence of a flame, should burn a sort of greenish color. Now, earlier, nope, actually I don't know if I mentioned that earlier. Earlier I said you could do some of these at home, like the baking soda and vinegar. Don't do this one at home. I'm a professional. I wear a lab coat. I know what I'm doing, mostly. So I'm going to light this on fire right here. There we go. So it's starting to burn that alcohol. It's starting to burn that borax now as well. We're going to see it start in just a moment. So we have an orange flame right now. It's beginning to burn that alcohol off. And we're going to start to see it work on that borax inside of the container. And we should get a green flame. If we don't, this is the part of the show where I say sometimes in science things don't always happen the way they're supposed to. This might be one of those times. While we continue to let that react together, I'm going to go ahead and set up my next container here. So we're getting a little bit of a blue color. I can see some green start to come in, but I don't think it's going to register on your end. Let's see if we, well, let's go a little bit longer here. It really wants to. I can tell it wants to do it. I don't think we're going to have much of a reaction. I'm going to go ahead and cover it up. What I'm doing right here is I'm taking away the oxygen. It's going to burn all that oxygen, and then it's going to stop that fire from continuing. So I'm going to do that, push that one off to the side, bring my next one in here. My next one is strontium chloride. So let's see if we can't get a little bit of a more visually appealing reaction here. I'm going to go ahead and actually try and turn off all of that. Yeah, let's try that. Okay. There we go. So my fire is lit, and we have a red colored flame on here. I think you can see that on the overhead camera a little bit better. We have a nice bright red flame happening right here. I don't know if you can see that. I think, yeah, that overhead camera, you guys can see that red pretty good there. So we have a nice red flame going. So that's my strontium chloride. So it's a chemical compound, and it's burning that, that alcohol that I had on there. But while it's burning that alcohol, it's also creating that red color. It's letting off that red color as it burns the rest of that chemical. It's very red on my end. I hope that communicates well over to you guys. I'm not sure how well you're able to see that or not. I bring up my lights. Is it a little easier to see on that red color there? It's kind of going out now. I'm going to go ahead and cover this one up here. We might try that one again here. I think if I have the lights on, you might be able to see it a little bit more. It looks like it's done reacting. There we go. Let's go ahead and go to this next one. This next one is called potassium chloride. Potassium chloride, when it is in the presence of heat and of a flame, it'll burn supposedly a purplish color. So let's see if we can't view that purple color. we go, it's ignited. We have a purpley color on our flame. I almost think, can you see it better with the lights on? Is that any better? No? Maybe it's just all a wash. I don't know. We have a little bit of a brighter view there. Maybe we come in on that overhead camera a little bit more. Oh yeah, you can see that on the overhead camera. Yeah, let's just do that view. Let's make that a nice big view there for everybody to see what's happening here. I wonder if I turn the lights off, you can still see that purple. Oh, there you go. Yep, that's a good one. So we have that purple color that we're able to see. Try that strontium chloride again. Maybe that makes it a little bit better. You can see some of that red color come in there. So that's our strontium chloride, that red color that we're seeing. So that one's working now. I'll try that borax again. It's really wanting to do some green. I can see a little bit of green. I don't think it's going to come across on that screen very well for you guys. It's burning more orange than green. It's not a very pure form of that borax. It's also not in your view of the camera, so it doesn't actually matter. So we're going to go ahead and cover those up, let them extinguish here. I have one more to show you. We'll keep it on that overhead camera. I got one more to show you. This is copper 2 chloride, and this is going to have quite the reaction. I'm going to get it nice and lined up there. I'm going to add in our fuel source. We might even do this one twice. It's going to, well, you'll get to see what happens. There we go. So this is actually boiling that chemical. It's actually causing it to almost harden and turn into a more sort of a rockish type substance. We're gonna do this again. Maybe we can put it on the front facing camera this time. We'll do it one more time so we can see that flame again. There we go. So there are little sparks inside of there. Bring the lights back up here. So it creates quite the flame, quite the view, my friends. And it's boiling and it's bubbling. And it's sort of becoming this hard black type of substance. Now I have one more reaction for you guys today. It's not so much a chemical reaction as it is a physical reaction, but it's using something called nitrogen. Nitrogen is an element that we have on the periodic table of elements, which is what we talk about for all of our chemicals. It's all on there, and there are a lot of different elements and chemicals, and they all combine together to form different things. Well, one of those is called nitrogen. Nitrogen is a gas, normally. You see, nitrogen as a gas is all around us. In fact, about 80% of our atmosphere is even made up of that nitrogen gas. It's, fine for us to breathe in, it's relatively harmless, but it does have one property. When you get it to be very, very cold, it turns into a liquid. And that's what we call liquid nitrogen. Which is what I have right here. In here, I have what we call liquid nitrogen. Now, liquid nitrogen becomes very, 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 very cold when you cool it down. Well, what that can do is it can change the properties of other materials around them. For example, right here, I have a balloon right here. This balloon, as it stands right now, looks sort of like this, right? It's nice and it's long, and it's not deflated, it's nice and full. Well, I'm gonna go ahead and dip it on in here. I'm gonna dip it on into that liquid nitrogen, and it's going to start to shrink that balloon. Now the balloon is starting to shrink because it is no longer, here you can really see it. The air isn't escaping from my balloon. The air is all still in there, but that air is being very, very cooled, very, very cold. The air molecules inside my balloon are becoming very, very, very cold. And so it makes my balloon sort of shrink up. Now, if I kind of wiggle my balloon around though, and I let it to heat that air molecules back up, the air molecules begin to stop condensing together and they start to expand and fill up my balloon as it begins to heat up, and it'll kind of keep going. None of that air was lost inside the balloon. It just condensed down. It got a lot closer together. All those air molecules decided that they wanted to be a lot closer together. And so they shrunk down as they got really, really cold. We're gonna do this one more time just as another demonstration. A little bit quicker this time. My liquid nitrogen is going to cool the air molecules inside of my balloon right here. My balloon's gonna start to shrink. Those molecules are getting closer and closer together, but they're not escaping out of the balloon. My balloon looks like it's deflating and looks like it's getting smaller, but it's not. As I wiggle it around, it's gonna heat up again. It's gonna make those air molecules nice and warm. They're going to inflate and expand just like so. Now, liquid nitrogen, it's already actually boiling and turning back into a gas right here. I'm gonna try to speed that up a little bit by adding in some warm water. There we go. Just like so. And we have this lovely reaction of that liquid nitrogen turning back into a gas. That concludes our experiments for today, but we do have plenty of time for a couple of questions. So I'm gonna go ahead and look on over to my friend working my computer back there, have her read me some questions. I'll repeat them so you guys can hear them as well, and we'll get on with our time today. So the glow stick experiment, in the addition to the hydrogen peroxide, what else do you need to make it glow? So you need to have a couple different things. The hydrogen peroxide is one of the chemicals inside of that glow stick. The other part of that glow stick is a chemical called, let me look at my notes, oxalate esters. And so they work together to create that glowing reaction as well as a little bit of dye. Now, in order to get that oxalate ester or that dioxalate ester, excuse me, some of these chemicals were named very complicatedly. I don't know how you do that, except for breaking open a glow stick. I've looked, I've tried, I've done my research. If you figure it out, let me know, because I would also like to do that, but I don't know how. Hopefully that answered your question well enough. So why is it so cold? So nitrogen at room temperature is a gas. It's always a gas, right, at room temperature. Just like if you boil water and you see that steam kind of come up, maybe you're making mac and cheese at home, right? You see that steam come off of that water, that becomes water vapor, or what we would also call a gas. Well, my liquid nitrogen is nitrogen gas that's been cooled down to a super, super cold temperature, and that's how it becomes a liquid. I don't remember the exact off the top of my head, but I do remember it's, what, negative 300 and something, 320 or so. Negative 320 degrees Fahrenheit is how cold it needs to get to become a liquid. So how did it get that cold? I'm not really sure. You condense the gas together. That's the first part. You have to condense the gas together. You have to add pressure, condense that gas together, add pressure, and it helps to cool and slow down the molecules so that they become a liquid. All right. It seems like that's the end of our questions. My friends, thank you so much for tuning in. That is the end of our very first homeschool virtual program. I hope that you enjoyed it. If you think of a question later, shoot me an email. I'll be happy to answer it then. We are going to start up our program in January in full swing. It'll include one live virtual performance or show like this a month, usually on the second Monday of the month, just like today at 2 o'clock. Now, more information will be coming to you in your emails. Parents, you should have an email with a survey asking you to fill it out, give us some feedback so we can really tailor this program to be what you and your families need, because that's what we want to do here at the museum. We want to reach you and your families as best as we can to engage the imagination and create excitement about learning. So thank you for tuning in today. That's the end of our program, and have a great rest of your day.